Hello, everybody. I wanted to debrief the exit ticket. I just wanted to remind you what the problem was. So it's similar in structure to the one that you spent a long time on in class. And my hope was that you would take away the idea that this structure is similar. And I'll show you what the structure is in just a second. But here's the problem. There's a famous number sequence, an infamous number sequence, where you start with any number. It doesn't have to be one digit. And then the way you calculate the next number is you see if your number is even, and if it is, you divide it by 2. If it's odd, you multiply by 3 and add 1. So here 3 is odd, so I multiply it by 3 and add 1 to get 10. 10 is even, so I divide it by 2 to get 5. 5 is odd, so I multiply it by 3 and add 1 to get 16, and so on. So it's believed that every sequence, so no matter what starting number you choose, if you follow these rules, you will eventually get to 1. I'm going to call the length of the sequence the total number of values that it takes for you to reach 1, including that last one. So if we count the numbers here, 1, 2, 3, 4, 5, 6, 7, 8, this sequence starting with 3 would be length 8 because it takes 8 numbers to get to 1. So with all that background, here's the question. Remember, brute force is about systematically trying all the possibilities for something. So I want to systematically try all the possible sequences with starting values from 2 up to 1,000, and I want to count how many of them have lengths greater than 100. And I'll do it on paper just to try and simulate the experience that you had, even though my handwriting is not the best, certainly worse than my typing. So the structure that I wanted you to take away from the in-class problem, I'm going to do sort of some pseudocode over here, is the idea that you're going to loop over all possible things, like whatever possibilities you're trying to loop over. And then for each possible starting value, like in class, the number sequences we did is we looped over all possible pairs of starting numbers. And then we would make the sequence. And then we would do things like check if it's the longest sequence so far or print the sequence. Here it's very similar. I'm still trying to loop over a whole bunch of possible starting values. I'm also going to make a sequence. But then what I want to do is I just want to say if the length of the sequence is larger than 100, then I'll add to a counter. Because my end goal here is to count how many sequences are longer than 100 in length. And then in the end, I would output the counter. So this is the sort of outline of the code. But the key thing to realize is, I think just glancing at the exit tickets, this is where most people went wrong. To make the sequence, you need another loop. Because this outside loop is just for looping over all of the possible starting values. And then once I have a starting value, I need another loop to generate all the numbers in the sequence from that starting value. So I'm going to try and follow this outline now. If I want to loop over all possible starting numbers, in my initial, or in the problem that we worked on in class, it was a double loop because we looped over all the one-digit first values and all the one-digit second values. Here, let me find a better pen. Okay, hopefully this will work. Here, we don't start a sequence with 2 digits and then like sum them. Here, just 1 digit is enough to start a sequence. So I'm going to name it first. And it said in the slide, I don't know if you saw it, but we're going to start with 2 and go up to 1,000. So I'll initialize first to 2. I'll say keep going as long as first is less than or equal to 1,000, and then I'll add 1 with each iteration. Okay, so I think the right thing to do would be to declare a method to make the sequence, which I could write over here and then use it. But I'm not going to do that because I think it's going to be easier for a lot of you to follow if I just put the sequence generating code right here. So I'm going to sort of draw a box here. Hopefully it'll be large enough. So now I've got my starting number. This code in the box is supposed to make the sequence. Okay, so if I'm making the sequence, I guess I'll need a couple of things. I don't want to change my starting number. I want to have a new variable. So I'll say num equals first. And so now now num is the number that I'm going to use as my variable for each new term in the sequence. I know I'm going to need a loop of some kind because I'm going to generate a whole bunch of terms. I don't know how many times I'm going to have to repeat. So a for loop is a bad option here. I think I want a while loop. And I actually know the condition that I want to use for stopping. I want to keep looping until I reach 1. So that means I want to keep going as long as the number isn't equal to 1. So while my number not equal to 1, I'm going to keep making new numbers. Okay, so I'm going to define a next number. Let's do this. Int next equals 0 to start with. And then I'll say if the number is even, so if I divide it by 2 and the remainder is 0, then I want my next term to be the previous term divided by 2. Otherwise, if it's odd, a number has to be even or odd. So I can just have an else statement here. If you said if num mod 2 equals 1, that would be a great test for oddness. I'll have my next value be the current number. I think it was times 3 plus 1. I forget. Let me check the slide. Yes, it was times 3 plus 1. Okay, so this green box here is generating the next number in the sequence. And now that I have the next number in the sequence, I will set num to be equal to that next number. And the reason I'm doing that is because I'm just about to end my loop here. And so once I got to the end of the loop, it'll come back up here and I'll say is num, which is supposed to be the last number I generated, is num equal to 1. If it's equal to 1, we'll exit because we're done. If it's not equal to 1, we'll go ahead and generate the next number using the rule. And then we'll take that next number and save it inside num as the most recently generated. Okay, so now I've got this box that has this loop that's making the sequence. So now I have to think, well, wait, what did I care about in the sequence? And now I go back up to my plan here and I remember, I care about the length of the sequence. Well, I'm not using an array list. I'm not using an array, nothing like that. So I think I'm going to need a counter variable to count how many total numbers were in the sequence. So here I'm going to insert those things in green here. So let's say right inside here before the loop starts, I'll call it num terms. And I'll start number of terms equal to 1 because I already have my first term. It's first. So if I was going to stop right away, the number of terms in my sequence is already 1. Okay, so now I generate the next term in the sequence and I assign it to num. And so as soon as I've done that, now I've generated one more term in my sequence. So it would make sense to update num terms. So I'll add to num terms. Great. So now that I've done that, I know that by the time I'm done with this box, now that I've come to the end of all the looping and my sequence has finally reached 1, I've counted the number of terms. And so now the rest of it is easy. I already have it up here. I just need to check if that length is larger than 100, and if it is, add to a counter. So that tells me I need another counter up here. Int, I'm going to call it number long sequences. So num long seek means how many long sequences have I found so far. And at the very beginning, I've found 0 long sequences. But down here, I can say if num terms is larger than 100, because remember num terms was how many terms I had in this process, then I can say num long sequence plus plus. And so that'll count one more long sequence. And now finally I will close my initial for loop. Something I saw a couple students doing, which I think is a great idea, is whenever you open a block of code, whenever you have an opening brace, remember to have a closing brace that's right underneath the beginning of that line. And so you can draw a vertical line to make sure that your braces all match up here. So the while loop I draw vertically down, and that closes it. The if statement, vertically down, and this closes it. The else statement, vertically down, and this closes it. It's a great way of making sure this if statement, vertically down, and this closes it. And then everything inside the code block, everything between the opening and closing brace is indented. And that's sort of a nice way of organizing to make sure that all of your code is where you want it to be. Okay, if you tried to use like an array list or an array to keep track of the individual elements, that's not wrong. You could still have a correct answer. But part of what you want to do in your programming is sit down and think, what variables do I actually need for what I want to do? And hopefully, I was hoping you would think about, all right, if I have, well, let's start with a different number. If I have a number, I just need one value to keep track of each digit until eventually I get to 1, and then I just need a counter to count how many times did that happen. There's no reason at all to save all of those intermediate digits. That said, I'm going to record one more video where I'm going to do this whole process one more time, but use an array list to keep track of the individual values.